take to raise a mushroom? Say to cover a roof, how much time? Is that cohesive material? Is it self-adhering?
Yes, yes. Okay, so first question, how much space does it take to actually grow this? So that tile you see can grow it's 18 inches by 18 inches, and that's how much space it takes to grow that sheet, right? So in terms of the actual environment that it needs to grow in, the best environment that it needs is a little bit of CO2, a little bit of sunlight, and a little bit of water, right? And then it needs just waste agricultural material. It takes cellulose, it takes cast off corn stalks and other things like that as well. So
what is the cost to manufacture that tile there?
Okay, so that tile itself is actually a prototype that we purchased from someone else as a means to start modifying and adjusting it and figuring it out in order to test with it. But the actual cost of that really depends on where we source the waste streams from. And sorry, to answer the second part of your question, so it takes about 3 weeks to grow into that big old sheet. So we're estimating that it costs less than $1 to produce a big old sheet like that. If only like 50 cents or less, because it's all waste product that is grown.
Is it moldable, like for instance, in the
Yes,
grade?
exactly. Yeah,
Substitute for
styrofoam. Yes, it's already been used as a substitute for styrofoam. That's actually where we got that product from specifically. We're modifying it to make it more of a structural building material. So pretty soon you'll see mycelium styrofoam cups. They're already using it as packaging material.
Have you all had about or using it for installation?
Yes.
Well, not for installation, but being able to mixing the material.
Yeah. So the question was, have we thought about using it as insulation material? That was actually one of the first thoughts because it came in looking like one of those ceiling tiles, right? Which is where the concept comes from. So there's already companies in the market that are moving towards that. Mainly because this mycelium over here is the very basic mushroom, right? They really haven't added anything, done anything besides baked it to an activated. That's basically it. Now there is a slight difficulty because it's a living material, right? So how do you make sure that it actually fully becomes biodegradable and doesn't start growing mold everywhere and other things like that, right? So this mycelium actually has been sitting for a good 2 months in a hot, humid environment, and it's still really, really structurally secure. So one of the things that we're looking into doing is taking the substrate underneath it, so the different cast-off corn stalks, cellulose, other things like that, a little bit of flour, and adding other materials as strengthening agents and whatnot so that you can put it in your ceiling tiles and other things. But yeah, that's an ongoing research process, but great idea, thank you.
You were talking about IP. When you're working with these big companies or competing against, for instance, the shingle companies, and the asphalt shingle market is just dominated by 2 or 3 of the big ones.
Yes.
How do you make sure that they don't copy you, basically, and just go without you?
Yes. Okay. So one of the initial concepts was patent resistance, and the actual process for patenting and going through all of that is something that we will do further on down the road. But the main initial conception is to get this out there and experiment with it. In fact, personally, and the rest of the company espouses the same idea. We don't care if it gets out there as long as it gets out there. This is a hugely beneficial building material. If I profit, if somebody else profits, as long as it's out there, as long as it's being used, that's really, really what we want.
So you mentioned from hardscape or landscape designers, in the sense of, let's say, an outdoor patio.
Yes.
Would you set the form and have it grow on site, or would it be grown in a facility, a warehouse, and then assembled?
Perfect. Actually, that is a further concept, right? So initially, what you have to do is inactivate it, and that's to ensure that it's bioinert, so it doesn't grow beyond its bounds, so that it doesn't affect anything else in the environment. Now, tapping into the biological potential to grow out in certain different ways, you could set it to grow into a patio, for example, further on down the road, and then inactivate it. could set it to just grow and be there and self-repair. So those different potholes that you run into on your way to work, on your commute, those will self-heal rather than be there, be static, and have people come in and fill them in. This is a biological material, so it's self-healing. It actually responds to the stresses of the environment to get rid of the stresses of the environment. So, great concept, yeah, we're looking into that. Dan?
Elliot, thanks for coming in and giving us your presentation on ViV today.
Sure.
Very well done. One of the things that comes to mind is in terms of mobilizing the company into some key reference accounts and in terms of fundraising, particularly on the equity side, a key component of that is the team. So what's the team look like now, and what are the key what are the key components of your team that you'd like to bring in?
Okay. So currently it's me, and I have a specialty in synthetic biology, which is modifying organisms in order to serve as different kind of functions. We have a mechanical engineer who's very interested in structures and in constructing structures. He's still a student in VCU, however. And then we have a third student who is in tissue engineering, into modifying different polymers and working to create novel polymers. So the three of us comprise the main body of the team, but we also have an advisor who's a professor of fungal biology, Dr. Tenho, who has been a huge help in advising us, helping us with mentorship. And then we also have another advisor in analytical chemistry, so working into the structure and whatnot, breakdown of the actual fungal biology. So that's the current team right now. But as always, I'm always looking for more help and more people to make this come about and start getting out there and being used in different ways. Yes?
How far away are you from having a piece of asphalt shape to kind of ship? That this was used for several clubs?
Yes. So what we've been doing over the past summer is actually helping build the lab in which we can start experimenting and whatnot. The lab is about 2 weeks away from being fully ready to be used. After the lab is used or ready to be used, it's going to be 6 months to a year before we have a viable asphalt shingle replacement. But even before that, what we can do is we can start selling things as means of generating income and revenue. I mean, as I said before, like different test interesting things and shapes, like mycelium busts, or growing out different kind of experimental artworks, making a small house out of this mushroom bricks, for example. Yeah, different fun things.
How much processing does it take to go from a mushroom to get to that? What do you do to it?
Okay, so the stepwise, and this might get a little technical for you guys, but we get pre-selected mycelium, which is already shown to have a very hardy stock, right? Very, very dense root structure. And what we do is that we inoculate it on petri dishes, right? You grow it out on a little petri dish for about 10 days or so. And once you have that, you have a stock of mushroom ready to go. And so you place it in and there's different ways to do this. What we do is we put it in a little bag, right? And it grows out into form that shape of the bag. And so that process takes about 3 weeks or so to grow it out of the bag. And you fill the bag with all the different substrate that you want to use. So, for example, cornstalks, flour, a little bit of sugar, and then fill it with water, make sure it's wet. But you have to do all of this in a sterile environment in some kind of way, right? So we inoculate, we do the petri dish under a fume hood, which is a kind of expensive piece of equipment that we're putting together and will be available soon. And then the second part of the process needs to occur in some sort of greenhouse-like environment. And so that's really all it entails. You can grow into any shape.
Well, you got a mushroom, but you grow it into the final shape like that?
Yes, yes.
I mean, that's it?
And then after that, the next step in the process is inactivating it. And all that really takes is baking it. There are different things that we're looking into in order to wash it with chemicals in order to fully kill any mushroom remaining. But the main difficulty in this material is, and what we're really experimenting with right now, is coatings. Because mushroom gravitates towards other mushroom, and they grow upon each other, right? And so what we've been doing is experimenting with different bioresins, which is basically like like sap polymer from trees in order to coat it, in order to inactivate it even further, to make the lifespan last longer.
Speaking of lifespan, what is the equivalent? Are we trading out styrofoam, which takes forever to decompose, with mushrooms, it takes forever to decompose?
Gotcha.
Could
So,
you repeat the question?
all right. So, what is the expected lifespan? Are we trading styrofoam, which takes forever to decompose, with another substance that takes forever to decompose? So, there's a number of things that are wrong with styrofoam, and I'm going to set that aside. But just chemically, structurally, other things like that. But mycelium, which is the root structure of mushroom, and the polymer underneath it, chitin, is able to be broken down by nature, right? There's different kind of enzymes and whatnot to break it down, but it takes longer. It's like your hair, right? You know how you find hairballs all over the place and things like that. Like it eventually degrades, but it takes a while. So your question to, are we trading one for the other? What's great about mycelium is that it can be easily broken apart in different ways, but you can control that degradation process. Whereas styrofoam, it's set. Styrofoam, you know that the polymer is a certain way. It's going to take about 1,000 years to break down in a specific environment. Whereas mushrooms, you can control, oh, it's going to take a week to break down. It's going to take 2 months to break down. It's going to take 10 years to break down, right? And it's all dependent on how you modify the process and go through it. So, for example, right now, that kind of thing, if you put it in the ground, it would break down in about a month to 2 months. So because it's self-extinguishing, it's probably not really conducive to being burnt. Like one of the things that we're really excited to do is a flame test with it. So it's where you take like a wood torch or something like that and you see how long it can last before like burning all the way through. So that kind of process, also burning releases CO2 into the environment and whatnot. What this actually does is store it and link it together and has it so that it lasts a little bit. So it could be burnt, but the energy involved in that process is probably not something that you want to do, right? It'll last as long as you want it. We're looking to a comparative degradation rate as asphalt roofing shingles, if not more so.
So we can let it use to be playgrounds.
That is actually an intriguing usage. So are you thinking about the mulch on the ground, or are you thinking about the actual?
I can't tell you how much they mulch. I have a almost 4-year-old. She comes home all the time with mulch in her shoes. It tells me about the mulch and how I'm like, I hate she's playing mulch like this. So maybe I get something else.
There you go. Yeah, she's standing on it over there. You guys are welcome to.
Yeah, just thinking, because I was kind of thinking along the same lines of a school or a playground or something where people would run where it's not impacting their way.
Yeah. It's a slightly springy substance. It's viscoelastic. Got it.
Yes, because we are architects and builders and entrepreneurs, we've been using cypress and often even experimenting with reclaimed cypress when we can get it. And I've wondered if you have thought of growing this on a substrate that when used as a roofing material lasted more than 100 years, has natural oils in it, offers natural rot resistance, all of that, and actually doesn't grow things that are harmful to us. If you're using maple, for instance, for your cutting boards, people already know this. So there's antimicrobial going on just in the cypress. Have you considered growing it on cypress and roofing applications?
So the question was whether or not we considered growing
Or
it
other.
in cypress or among other biologicals, right? Other kind of
To adopt the
wood-based-
properties.
Yes, yeah. So the entire experimental process right now, one, just establish the lab, right? If we get the lab going, if we have like a good experimental environment, we can start creating different things. The second step is to test out different substrates and further processes. So different wood substances, wood chips, sawdust, other things like that is immediately on our docket, right? So that's certainly like the first test environment to go to. We hadn't considered cypress though. It seemed a little cost prohibitive. I don't know.
We're a wholesaler, moving dog.
Perfect, yeah, awesome.
Elliot, just on a separate point,
Sure.
one of the things that's a big issue of discussion in terms of social impact and sustainability broadly is sustainable housing.
Mhm.
And so when we look at that as a global issue, and I'm thinking of Peter Conradi from ZagTag, is sitting in front of me here, who's from South Africa originally. And so when we think about that globally, half of the population, over 3 billion people on the planet, live on about $2 a day, right? So is there a way to think of this in terms of an export opportunity to address sustainable housing applications internationally? And what might the first couple of steps look like to do that?
Yeah. So in looking at the developing world, the huge economic powerhouses that are coming out of India and China actually take up most of the building, construction, minerals, resources in that environment. So they're using 5 times the amount of building construction resources as the U.S. And that's a huge amount. It's a huge disparity, right? And the vast majority of what they're running on is concrete, asphalt, really dirty pollutants, not alternate sources of building materials. I received a question before about using mycelium as an alternate building material, and they said, how are you going to compete with the oil industry, with asphalt, which is using oil as a byproduct, as a waste stream? And the answer I had to them was that we're also using waste streams. We're using agricultural waste. We're using paper byproducts. We're using cast-off seashells and other such carbonates in order to structurally adhere to our material. So that kind of cost-benefit balance kind of thing, I can definitely see occurring in the developing world and in the rest of the world as well.
We would like to thank Elliot for his time. He also has his business cards up at the table, and you feel welcome to speak with him after our meeting. Thanks again for visiting One Million Cups. We look forward to seeing you guys next week. Thank you.